Hello, my name is Kate Zimmerman, and I'm a Principal Deep Learning Architect at Amazon Web Services. In today's session, we'll be discussing one of AWS's AutoML services called Amazon SageMaker Autopilot. Launched at reInvent in 2019, Autopilot automatically trains and tunes the best machine learning models for classification or regression using your data, while allowing you to maintain full visibility and control of the machine learning lifecycle. What we'll be covering today is a high-level overview of Autopilot, discussing the motivation and philosophy behind the product. We'll then dive into the features of Autopilot. I'll show you a demo of Autopilot in action. And then we'll end with a couple of stories about how customers are actually using Autopilot today in their actual environments. So let's go ahead and get started. The mission of Autopilot is to empower customers to use machine learning without requiring deep machine learning expertise. So according to QuantHub, there are 3 times more job postings than job searches for data scientists, and data science is the second most in-demand tech role today. The first being cybersecurity engineers, of course. But the reality is that scaling data science expertise in a company takes a lot of time and can be pretty expensive, which is why we built Autopilot, so that all customers can easily create the best production models regardless of how extensive or experienced their data science team may be. So at a very high level, Autopilot works like this. With SageMaker Autopilot, you provide a tabular data set and select the target column to predict. This could be something like a number, so a house price could be an example here, which would be called regression. Or it could be a category, so spam, not spam, which would be called classification. SageMaker Autopilot will automatically explore different solutions to find the best model for your data. And then you can directly deploy that model into your production environment with just one click. So the first ingredient for using SageMaker Autopilot is tabular data. So what is tabular data? Well, when I say tabular data, think CSV, spreadsheets, relational databases, Excel sheet, rows and columns. Tabular data is a structured data set, and as you may have guessed, it also happens to be one of the most common data sets that you'll find out in the industry. And in this example here, you can see that we have 4 columns, so variables 1 through 4, which would be, we could say, I don't know, sensor data or something. And then the target column is what we're trying to predict. So in this case, we're doing what's called a binary prediction of a 0 or a 1. So we're trying to classify this. And so this is an example of the type of data that you would put into Autopilot to build a machine learning model. Now, because tabular data is so common, the use cases here really are pretty much endless. I have a few listed here just to give you an idea of ways that we've seen our customers leveraging Autopilot, but this is by no means a complete list. One of the data scientists I work with, he actually used Autopilot for detecting anomalies and shipping patterns using a data set for that. Now, a couple of cool things to highlight here is that in addition to downloading your data, so let's say you have a small data set, you can download that data and upload it directly into Autopilot. But if you're working with very large data sets, you also have the option of doing things like connecting your Redshift cluster or using Amazon Athena or any other AWS database directly within your SageMaker Notebook instance. So it makes it very easy for you to work with very large data sets within Autopilot and be able to train models across very big amounts of data, which can be a pain historically. So it's a very nice piece of integration that we have. So to fully understand how Autopilot can help you automate the creation of these machine learning models, I'd like to spend a quick moment to understand, and walk you through how resource intensive it can be to build an accurate machine learning model. So, ta-da, the machine learning lifecycle. Again, this is, I think, a very common set of slides that we show here at Amazon, but it is truly important to understanding and appreciating just how much Autopilot is doing for you. So whenever we start building a machine learning model, the very first step is to perform data preparation and feature engineering. So some basic techniques that might happen here could be, imputation with missing values, or maybe taking some of your columns and converting them to categorical features or binning them, etc. And typically this process is going to be done by a data scientist on your team who has some familiarity with the data set, hopefully, And it's usually pretty manual, right? So they're going to take a guess of what features they think will be good predictors for model training, but there's no way to really know which features will perform best, or at least it's very rare that you know that at the outset. So typically what you have to do is take your best guess, train the model, and then go back and revise your guesses there and iterate to find the right features that you need to be able to build an accurate model. So, as I mentioned, the next step, of course, no surprises, then training. So you prep the data, you do some feature engineering, you train the model's garbage, you go back, you do some more feature engineering, you change some of the way you're prepping your data, you train the model, maybe it's a little better, maybe it's worse, I don't know. But then you typically iterate here back and forth. It can be worse sometimes. I've had many of times where I've done feature engineering, I train it, my model's okay, I go back and change my features and my model's worse. It happens a lot. It's super iterative. Like I said, this is a lot of the guesswork, but also a lot of learning about the new data sets. Once you get a model that's halfway decent, you move into model tuning. So here's where you're turning knobs, pulling levers, adjusting different hyperparameters to be able to fine tune that model to get as much performance out of it as you possibly can. So again, this process is also quite iterative. You take a best guess of which hyperparameter is going to be the best, and then you give it a try. If they're not the best, you try again. So you iterate here a fair bit as well. And again, these are all typically done quite manually by a data scientist before finally getting to the point where you can deploy the model into production. So at this point, our model is tuned up, it's performing well, it's meeting our expectations. And so we get to this place where we can finally get it into production and be able to actually get machine learning insights from our data for our business. Now, it'd be nice if this is like a linear thing. We just steps 1, 2, 3, 4, and ta-da, we have a model. But the reality is it's a lot of back and forth between steps 1 and 2, 2 and 3, 1 and 3, etc. And so, you can think of this as more of like a scientific process. So your data scientist is going to have some kind of hypothesis about what the best approach will be. They're going to experiment. They're going to learn more about the data. They're going to adjust their hypothesis, and they're going to repeat until we get to the point where we have a model that's ready for production. So this process can take some time. It can be quite manual, and it can be quite resource intensive. And this is the process that Autopilot automates. And so with Autopilot, you can use a single API call or a few clicks in the Amazon SageMaker console, and Autopilot will be off. It first inspects your tabular data set. It runs a number of candidates to figure out the optimal combination of your data, pre-processing steps. So it's actually automating step 1. So it'll try a bunch of different feature combinations, and it actually gives you output along the way to let you know what it's been trying. And just like a fun little story here. So a data scientist that I work with, who is kind of a total nerd, he trains models all day, that's his job. He was telling me that he actually had spent weeks trying to manually do feature engineering on a data set, and he kept getting poor results coming out of the model training. So, when that happens, there's one of two things that could have occurred. First could be the data, it's bad. So you're not going to be able to build a good model with that data for whatever reason, or his feature engineering needs improvement, right? He's not deriving the right features from the data. So he decided to give Autopilot a try, and he actually was able to go from 76% accuracy on the model to actually 91% accuracy. And as it turns out, the optimal feature combinations were not very intuitive. So the insights that he gained from Autopilot and all the different feature combinations it's trained were able to inform him of which features made the most sense for that particular data set. And then using that information, he was able to then train additional downstream models that improve that accuracy even further. So in addition to the feature engineering piece, Autopilot then trains hundreds of machine learning models. It tests different hyperparameters. And because it's all taking place on Amazon SageMaker, it's using this fully managed infrastructure. And so it's very easy to do. For all you budget people out here who might have had a heart attack when I said it trains hundreds of models, some cool things that Autopilot also does is it optimizes the instance size that it trains on. It turns the instances off and on automatically. And so it is optimizing for cost along the way. In fact, most of these training jobs only take a couple of seconds. So I would argue that it's actually an extremely cost-effective way to do building these regression and classification models, because it's very optimal in how it uses the resources within SageMaker. And as you're getting all these results coming out of all these models and the model tuning and the feature engineering, all of that data is shown to you so you understand exactly how your data was pre-processed, what accuracy metrics it used, any kind of flags that might be, data quality issues get presented to you along the way. And I'm going to show you guys this a little bit later, but that full transparency thing I think is very unique to Autopilot and a very powerful feature that it has to offer. So I know I've mentioned most of these, but I really want to kind of foot stomp the core features of Autopilot. The first one being that it's very easy to get started with. So you just need input data in the tabular data format, and Autopilot is going to do all that automatic data cleaning and pre-processing and feature engineering work for you. It then does automatic model creation through algorithm selection. So it actually is going to try a bunch of different algorithms. So it'll try things like linear regression, binary classification, and multi-class classification. It also does automatic hyperparameter optimization too. And if you have a really big data set that requires distributed training, it's going to stand up distributed training for you. It's going to automate the selection of the instance and the cluster size and all of that to optimize for cost during your training jobs. And of course, you get full visibility and control throughout. So you know exactly what feature combinations it tried, which ones worked, which ones didn't, what metrics it used to determine what was good and what was bad. And you also get a leaderboard of the models that you trained. So hundreds of models, you don't want to go through that by hand to figure out which one was the best. So you get a nice recommendation, leaderboard that tells you these are the ones that were the best performers, which you can then leverage for further optimizations and model training if you need to. And because Autopilot is built on top of Amazon SageMaker, you have ability to manage and control access to the permissions for the models, the data, and all the other resources. So Autopilot saves your model artifacts into a user-provided S3 bucket. This allows for easy configuration of authentication, authorization of all the artifacts that are produced by an Autopilot job. In addition, administrators can easily and comprehensively control access and permissions to all the resources in SageMaker, including your saved models, your endpoints, batch transform jobs, with IAM users, roles, and policies. So you can really control who can access what, who can spin up what resources, what data they can access. And this is all going to be built on top of the existing SageMaker infrastructure. And kind of the last thing I want to highlight here is that Autopilot also is enabled for compliance with multiple standards, including SOC, PCI, FedRAMP, HIPAA, and others. Now, I feel like I've said quite a few times now that it's really transparent, it's great, it's really transparent. Probably one of my favorite features, so I just want to show you real quick here, and I'm going to show you again the demo because it's my favorite feature, is that when I say fully transparent, you actually get a notebook, like an EDA notebook out of Autopilot after you do your job. So you kick off the Autopilot job, it tells you, hey, here's the models that are great, and here's an EDA notebook for you. I'll show you exactly what features I've tried, and it's going to be like hundreds of feature combinations. And so this notebook is going to help you understand exactly, what flags it might have found. So you have a bunch of missing data, weird distributions. It's going to let you know in this notebook that those were things you might want to go back and correct for potential optimizations. And it's also going to, show you exactly what it tried, different feature combinations and such. So it's a really, I think, powerful thing to have this notebook. It's all executable code too, so you can take that and run it elsewhere. In addition to the EDA notebook, which, by the way, I forgot to mention, exploratory data analysis, if you aren't familiar with the acronym, EDA. But in addition to the EDA notebook, you also get the model candidate notebook. So you get, okay, here's how I did my data preparation, here's how I did my feature engineering, that's notebook 1. Notebook 2 for model candidates is then here's all the models I trained and here's all the hyperparameters I tried. So like step 2 and 3 of that life cycle. And again, this is a fully runnable notebook, and it's kind of like a blueprint that shows you how Autopilot built your model. It lists the transformations that it was used and also, which algorithm that it used. So did it use XGBoost, linear learner? Did it use the neural network algorithms? And then it gives you the results around those too. So this is really useful to explaining to your data scientists in your team or perhaps to your leadership, hey, like here are the models we tried, here are the ones that look the best. This is why we think these models performed well. So it gives you all that information so you can go forth and have those conversations. So Autopilot is not a black box. You get full insights into all of the different ways that it trained your model. And it's the same amount of information you get if you trained it, yourself from scratch. It's just automating that. All right, great. So let me go ahead and show you guys a quick demo of how Autopilot works. I'll show you guys the UI for all of this and how you can get started in the console. So with that, let's jump into the demo.
All right, So let's get to the demo. So here we have the Amazon SageMaker landing page in the AWS console. And you can get to this by just going to Services and then Amazon SageMaker. And what we're going to do for this demo is we're first going to go into Amazon SageMaker Studio. And we're going to open up our Amazon SageMaker Studio notebook. So let's give this a quick second here. Cool Jupyter Lab logo. All right. Now, what I'm going to show is two different ways that we can create an autopilot experiment. The first would be to come over here onto the left side of your Studio Notebook and click on the little beaker. And then from here, we can click Create Experiment. We'll give our experiment our name, so Autopilot Demo. And then we specify our training data location. So for me, this is living in a bucket that I created for this demo. So that would be re:Invent Autopilot Demo train_data.csv. Next, we need to specify is a target attribute name. So this is the column that has our truth data in it. And I'll show you this data set in just a moment here so you can see what I mean. But for us, this is called churn question marks. That is the column name. And what this column contains is true or false values. So a true value means the customer churned and left to a different company, and false means they stayed with our company. And then finally, we need to tell Autopilot where our test data lives. So this is in the exact same bucket, re:Invent Autopilot Demo, under test data.data.csv. All right. Now, I mentioned earlier that there's support for binary classification, regression, and multi-class classification within Autopilot. If you know what problem type you have, you're welcome to select the specific class of algorithm you'd like to try, but otherwise you can always leave this as auto, and Autopilot will figure out which class fits your data. Similarly, we're going to run a complete experiment today, but if you just wanted to generate those candidate notebooks, you have the option of doing that as well. But again, for this demo, we're going to run the experiment to completion. So what I'm going to do now is click Create Experiment. And ta-da! So here we are. Our autopilot job is now running. So it takes a little bit of time to get started. So what I'm going to do now is actually dive into some alternative ways to use autopilot. And I have a completed job that I'll show you guys to show you the results. And so to dive into the actual data set itself, now what we just did was create an autopilot job through the UI. And for those of you who are more comfortable with Python, you can create autopilot jobs within the Python SDK. And that's exactly what this notebook is doing. So here we're using Python code to do exactly what we just did on that previous screen. So what we have is our same data set. So this is that customer churn data set. But here we can actually see it in a little more depth. So let me move this over so we can see it a little better. So we have 21 columns in our data set. So we have the actual information about each customer and their utilization in their accounts. So we can see like what state they're from. We can see that they have voicemail plans, what time of day and for how long do they make calls. Have they had interactions with our customer service? How frequently? And then we have our final column. This is that churn question mark. This is our target attribute, which is going to be true or false, where true indicates that the customer has churned, so they are no longer with our company, and false means that customer has stayed with our company. So this is the value we're trying to predict. So our goal of our algorithm is to say, given all these attributes about a customer account, do we think this customer has a high probability of churning and moving on to a different company? And if so, perhaps we can then go take some actions to target them, maybe give them some coupons or follow up with them via email and just kind of, hopefully prevent that from happening. But that's what our model is going to try to predict. That's what that target attribute column is this churn column here. And as I had said, this notebook is doing the exact same thing that I did in the console, just using Python code instead. So here we have our input data config. So our data source, our training data, is going to be that train_data.csv. Our target attribute name is churn, and then we also have our output data path. So this is, again, very much the same configuration of what I did in the UI. We're just using Python. and then we can create an autopilot job using the SageMaker SDK. And in the notebook, we can see what's happening as well. So here we have analyzing data, feature engineering. So this is the same output that we see in this much slicker looking UI, but it is the same information being displayed back. So it does do the same thing. You can do it in Python or through the UI. Now, as I mentioned earlier before we started into this demo, you get two notebooks that come out of an autopilot experiment. The first is this data exploration notebook, and I totally cheated and I pre-ran this experiment for you guys so that we could see the results immediately. And so this is actually the data exploration notebook for that customer churn data set. And what's cool about this is that it has these suggested action items. So it recommends things that you can do throughout your data set to help prepare it and better improve your model performance. So first, it shows us that our data has loaded in correctly. As you see, this table looks very similar to one I showed you before. That's a good thing. That means that we properly passed our data to our training algorithms. And then we can see some other things it does. So here it says we found 0 out of the 21 columns that contain missing values. If there were a lot of missing values, that could skew our model performance. And if there were, it gives you some recommendations of ways that you can improve that. Similarly, it has counts as for categorical features. So we can see, for example, churn, there are 2 unique entries. That makes sense. We have true and false. So we could make that a binary. 0 could be false and 1 could be true. And so this is the kind of things that we get captured in that data exploration notebook. So if you're new to machine learning, as you could imagine, this would be very useful to have. If you're not so sure about what types of feature engineering techniques you need to be applying to your model, you could run an autopilot job and then go through this notebook and understand what changes you might be able to make that could improve the model performance. And so it gives you some nice recommendations to get started from. Similarly, we have the autopilot candidate notebook. So this is going to give us some more detailed information on the models that were actually built. So there's that feature engineering piece, and then there's actual model training that happens within autopilot. So here we can see that the data set has 2 classes. So autopilot automatically determined that this is going to be a binary classification problem, right? Binary 0 or 1. And then it gives you an idea of, it tells you exactly what to try to maximize. So maximize the F1 quality metric. So again, this text is telling you the strategy that autopilot used to train your models. And as you go through it, then walks you down through each approach that it used to include the feature engineering techniques, the types of algorithms that it applied. And it's actually executable code, which is really nice. You can reuse some of this code. And so here we can see we used a DPP0XGBoost. That was the first experiment that it ran. And it tells you that it used the data transformation strategy first transforms numeric features using the robust imputer. And then categorical features were encoded using the threshold 1 hot encoder, text features using the multi-column TF-IDF vectorizer. And if those are just big words and you don't know what I said, don't sweat it. That's the whole point, right? Is that it did these different pre-processing techniques to improve model performance. And if we go and click on any one of these, so if we look on the robust imputer, we can actually see the source code that it used to do that. So when we talk about full transparency, this is exactly what I'm referring to, is that we understand not only the models that were selected, but also techniques that were applied to do feature engineering to those models. And it also flags potential areas in the model where performance might be getting impact due to the data not being perfectly cleansed or having some kind of errors within it. And so this is great, again, for understanding how the model is making its selections and performing. If you needed to do additional work beyond the models that Autopilot generates, this gives you a really good understanding of what feature engineering techniques perform better than others. And also, you know, if you get the model coming out and it's looking great, you have confidence that, you know, if you ever needed to go back and understand why the model did perform a certain way, that data is there. But if you don't need it, then you don't need it, right? So it's good to have and not need versus the other way around. And so this is how Autopilot works. This gives you an idea of the outputs of Autopilot. And I just want to quickly call out, and I'll show you guys, sorry. I think I got ahead of myself there. I want to show you guys real quick here what this would be like without Autopilot. So this is that exact same data set. And instead of just running, putting a couple of lines in the UI or executing a couple cells in a notebook, doing this by hand requires a lot more work, a lot more knowledge about statistics, machine learning to be able to yield very similar results. So as I'm scrolling through here, and I know I'm scrolling fast, but you can see this is just general statistics in the data set. And we have to do all this work to figure out how we want to do the feature engineering to pare down our models and pare down our features. So the same techniques that were applied here, again, my fancy words like the imputer, where did that go? Geez, so much. Okay. So figuring out that we need to use the robust imputer and one-hot encoding and this TF-IDF vectorizer. To know that we need to do those things, we have to do a lot of analysis up front. And this, I'm still scrolling, guys. This is a lot of scrolling. This takes a long time. It takes a lot of work. It takes a lot of know-how and understanding of statistics, data sets, how machine learning algorithms work. And so Autopilot saves a lot of time by just allowing you to just click a couple of buttons and then it's off doing its training. And so you come back here in a couple hours and magically you have these notebooks that tell you how your data set performed, potential flaws in your data set, as well as a list of candidates for a quality model. So as you can imagine, this is a significant time saver, a huge advantage for those of you who may be newer to machine learning or not have a lot of machine learning experience. In fact, truly you don't need any machine learning experience to be able to use Autopilot. As you saw, it really was just a couple of clicks in the console. All right, and we can see this demo. I'm running it live, guys, is that our analyzing of data has been done. So we can actually now start seeing our notebooks. Now these are gonna look very similar, of course, to the ones that I just showed you because it's the same data set. But these are the outputs that you'll be getting from your Autopilot job as well. And so that concludes this demo. And all of this material that I have from today's demo is available in the Amazon SageMaker Examples GitHub repository. So feel free to execute these notebooks yourself, get hands-on, experiment. I always feel like that is the best way to learn. We also have some very helpful blog posts and tutorials published on Autopilot that are great resources for getting started and experimenting so that you can understand how Autopilot might fit into your workflow, your business use case, your mission use case, whatever it may be.
All right, great. Well, I hope you enjoyed that demo. And I wanted to finish off today's presentation with a couple of examples of how businesses are using Autopilot today. The first one is Freddy's. So Freddy's frozen custard and steak burgers. They actually wanted to use machine learning to optimize their menus and better incentivize guests at different locations around the country. So what they did is they used the Domo Data Science Suite, which is powered by Amazon SageMaker Autopilot. So within the Domo Data Science tool, you'll find an AutoML option underneath the hood that's actually being powered by Autopilot. And they were able to build machine learning models that can make predictions based on the menus and the price changes. So the result of this was that they saw a great increase of foot traffic in the restaurant. So it was a very good result. And one of the cool things is that thanks to the ease of Autopilot, they were able to use a data set that was 5 times larger than what they were initially experimenting with. And that's because Autopilot automates all of that data exploration stuff, that data prep. It's much easier to sort through large data sets and be able to train these large models with just one click. And this model was able to also yield more accurate predictions, right? When you have more data, you typically get more accurate predictions. And this actually accelerated their time to market by 2x. The next customer I want to highlight is Skullcandy, who manufactures headphones. And so another customer that's out here leveraging Autopilot. Whenever COVID hit, many people transitioned from working to home, working in the office, working at home, and Skullcandy experienced a large surge in order volume, which started to overload their system, and it actually led to a spike in customer service interactions. So by leveraging the Sisense platform, which again also has SageMaker Autopilot built in, they were able to quickly build machine learning models that help them better understand the relationships between customer satisfaction, contact channel, product, and contact reasons. And this has helped them more easily identify key topics or products that improve their customer satisfaction. So you joined the AWS Summit to learn, and you can keep learning, keep this learning going after the summit with resources from AWS training and certification. We offer over 65 courses available free and on demand, as well as virtual instructor-led training. AWS experts will help you or your team apply machine learning to your business, unlocking new insights and value. Just a quick plug, we also have a lot of great material out there on AutoML and Autopilot if you are interested in getting hands-on and learning more about this service. So with that, I thank you for your time today. Thank you for attending this session. I hope you learned something new, and I do ask that you please complete the session survey at the end. That feedback is very helpful for me to improve and give better presentations in the future. So again, I thank you for your time.